Okay, so in this video we're going to take a look at numbers 15 and 16 on our sample final. So problem 15 states a particle moves along the x-axis with an acceleration given by a of t equals 6t plus 2, where t is measured in seconds and s, which is your position, is measured in meters. If the initial position is given by s of 0 equals 3 and the initial velocity is given by v of 0 equals 4, then find the position of the particle at t seconds. So here's what we're going to do. In this motion problem, we're essentially going backwards. We're going to start with the acceleration function, use it to find the velocity function, and then use the velocity function to find our position function. Now notice that in this case, when we're trying to find the position of the particle at t seconds, we're just looking at a specific position function here, and in this case here, we don't necessarily have to plug in any values to find the position. In other words, when I find my equation my function s of t, I don't have to plug anything into it. Once I find it, that's it. So, let's begin. Well, first, you want to find your velocity function. If you want to find the velocity function, which is v of t, you're going to have to do two things. One, you're going to have to take the antiderivative of your acceleration function, and two, you're going to have to use your initial velocity of v of 0 equals 4 to get your specific velocity function. Observe. What we have is v of t is equal to the antiderivative, or the integral, of a of t dt. Now, since a of t, your acceleration function, is given to be 6t plus 2, then we're computing the indefinite integral, or the antiderivative, of 6t plus 2 dt. Which means that now I can take the antiderivative of 6t and take the antiderivative of 2. So what we're going to get is the following. If I apply the power rule on 6t, now again, this power rule that I'm applying is the power rule for integration. That means that since t is raised to the first power, I have to add 1 to its exponent and then divide by its sum. So we're going to get 6t raised to the power of 1 plus 1, which is 2, divided by that sum, plus the antiderivative of 2. Well, since 2 is a constant, when you want to take the antiderivative of your constant, it will be the constant times the variable of integration, which is t. So the antiderivative of 2 is 2t. And finally, because we're dealing with an indefinite integral, then this is going to be plus c. So we're going to simplify this. We're going to get v of t equals 6 over 2 is 3, so you have 3t squared plus 2t plus c. So now this velocity function that we obtain here is a general velocity function where c, let me just repeat this. Our velocity function here, 3t squared plus 2t plus c, is a general velocity function where the value of c can be any real number. Now, if we use our condition, our initial condition that v of 0 is equal to 4, we can get the specific velocity function for this problem. So, using, made a mistake there, v of 0 equals to 4, it follows that v of 0 is going to equal to, well, wherever I see a t, I'm going to replace it with 0. So we're going to have 3 times 0 squared plus 2 times 0 squared plus c should equal to 4. Well, when I solve this, or I solve for c, we're going to get that c is equal to 4, right? Because 3 times 0 squared is 0, 2 times 0, this should have just been 2 times 0. 2 times 0 is going to be 0. So you're left with c is equal to 4. So the specific velocity function that we wanted now is going to be 3t squared plus 2t plus 4. Now that we have our velocity function, we can find our, we can now find our position function s of t, and we'll also have to use our initial condition s of 0 equals to 3 to find the specific position function for this problem. And that will basically be it. So what we're going to do is the following. If you want to find the position function s of t, is basically going to equal to the antiderivative of your velocity function, v of t dt. So we're going to get the antiderivative of 3t squared plus 2t plus 4 dt. And if we integrate this, again, we will use our power rule. It's going to follow that we'll have 3t to the third over 3 plus 2t to the second over 2 plus 4t plus c, our arbitrary constant, right? Why am I using a plus c? It's an indefinite integral. Now we simplify. The 3's will cancel, so you're going to have t cubed. Your 2's are going to cancel, so you'll have t squared plus 4t plus c. So what this represents is the general position function, but we want a specific one where s of 0 is equal to 3. So using s of 0 equals 3, it follows that it follows that now s of 0 is going to equal to 0 cubed plus 0 squared plus 4 times 0 plus c is equal to 3, which then implies that c is equal to 3. So since c is equal to 3, I can plug that into our general solution for s of t, so that way we can get our specific function. So our position function, s of t now, is going to be t cubed plus t squared plus 4t plus 3. And that's it for this problem. If I wanted to figure out the position at any time t, I can just plug in now t into our position function and solve, right? So if t was equal to 1, then it would have been 1 cubed plus 1 squared plus 4 times 1 plus 3. Let's see, that would have been 1, 1, 4, 3. That would have been 9. It would have been 9 meters. And that would have been it. So that's all to problem number 15 in this motion problem. You're given the acceleration function. You'll have the initial position along with the initial velocity. You're going to use it so that way you can find basically your position function.